Okay, guys, good morning. Welcome back to my YouTube channel. Again, this is Mr. Santos Capellan Jr., always wishing you a good day. Guys, today what I'm going to do is try to discuss or give you an idea what is chilled water system using water cooled chillers. Okay, so what I have here in my screen is a cooling tower condenser pump. Okay, but let me begin it with the chillers. Okay, so I have here the water cooled chillers. Okay, now previously I have shown you the air cooled chillers. Okay, now today I will try to give you an idea about water cooled chillers. So I will not simulate the operation. I will just show you my prepared graphics for water cooled chillers. Okay. Now, as you can see here, I have two chillers, chiller 1 and chiller 2. Okay, so this is the graphics I'm using for a water cooled chiller. Okay. So first, what is the difference between a water cooled and air cooled chillers? It's very obvious. Water cooled chillers, they are using water to cool the chillers. Actually, what they are cooling is the refrigerant. Okay. So water cooled chillers, they are using here refrigerant, and likewise also in air cooled chillers, they are using refrigerant to chill the water. But in air cooled, they are using air through a condenser, air condenser. Okay, then here we are using also here a water cooled chiller. Now the water that is being used to cool the refrigerant is coming from the cooling towers. Okay, so this is the cooling towers. Okay, so let me go back to the chillers. So I want to discuss it one by one. So I can say this is part one of my water cooled chillers. Okay, so what are the points? If you have seen my previous tutorial, so meaning the points are almost similar. Okay. So here in the chillers, I'm only showing the what are the typical points in a chiller. Okay. So here I have not shown here the butterfly bulb. Okay. Actually, I have here a butterfly bulb. Okay. So there should be also a butterfly bulb here. Okay. Or you can put it in the chilled water primary pump, secondary pump. Okay, so maybe we can put the butterfly bulb here. Okay, the butterfly bulb here. Now it will depend on the mechanical people who are doing the actual piping for the chilled water pipings. Okay, so most likely they will put the butterfly bulb here. Okay, so maybe later I will try to edit this graphics so that I can show also the butterfly bulb. Okay. So in water cooled chiller, we have likewise we have primary pumps. Okay. So then we have also secondary pump. Now the primary pump's purpose is to cool the actually this not it should not be from tower. It should be from cooling load or from the building. It should be from the building, not from the tower. Okay. So you need I need to change this from the building. Okay, building load, then the chilled water will be pulled back and pushed to the uh, chiller cooler. Okay, so let's say this is the chiller cooler, and the above one we can say that is the condenser line. Okay, so as you can see here, this chilled water pump will try to pull the chilled water from the load side, then it will be pushed inside the chiller, whichever is running. Okay. So then, of course, obviously the butterfly valve should be open here if this chiller one is working. So meaning if chiller one is working, there are around, okay, it will depend on the actual site installation. Maybe you have here one butterfly bulb here, then another butterfly bulb from the condenser in incoming and outgoing. So obviously, or maybe there will be four butterfly bulb each chiller. So two for chilled water and two for condenser water. Now guys, of course, it will always depend on the site installation. Maybe you have here isolation bulbs manually open and close. But for the control, we have the motorized valve. So butterfly valve with valve actuators. Okay. So when the chiller is working, those four valves will be open. Okay. Then the secondary pump job is to suck that chilled water. Then uh, put it to the building load. Actually, to tower load. Maybe from tower, meaning from tower, this one is not from cooling tower. From tower meaning is from the tower or the building. Okay. So maybe I referring this one from tower. The not the cooling tower. Okay. So this one to tower load. Okay. So it is now clear. So guys, what are the points? We have the hand of auto status. Okay. Then we have the enable run status. Then water flow. Now water flow. Okay. Of course, this chiller, as I said, each chiller has its own built-in control. Okay. So the chiller plant manager or the DDC dedicated for controlling the whatever we need to control in the chillers will be handled by CPM, chiller plant manager, or the DDC dedicated for these chillers. But the chiller itself, it has its own control because the chiller, it has its own it is a standalone system. Of course, so there will be a microprocessor based controller that is controlling the internal, okay, the internal control of the chiller. Okay. Now for the DDC or the CPM, we are controlling only, let's say we are controlling the valves here and the pumps. Okay, but internal chillers control will be handled by its own DDC or PLC. Okay, so let me stress that one. Okay, so you should not be confused of chiller own internal control, then the system control as a whole, because this is a system, water cooled chiller. So this is a system, meaning there will be some like primary pumps. Then we have secondary pumps. We have these butterfly valves, uh, butterfly valve with valve actuators. So this one will be the one that you are going to write the control. Okay. Now we also have to monitor some of the parameters like the temperature, the entering chilled water temperature, and the leaving chilled water temperature. Of course, I'm not showing here the condenser part. It will be shown in another graphic because I don't want a very complicated graphic. So this one is only dedicated for water-cooled chillers. Okay. So chiller 2, likewise, we have the butterfly valve. Then we are also monitoring the tree. Now, for the chillers, they have their own parameters which is being monitored and controlled by the internal control of the chillers. Okay. Now those like what is the current being drawn by the chiller, or what is the status of the flow, or what will be the flow, because maybe there is a built-in flow meter here. Then what will be the temperature, or so many things that needs to be monitored inside the chiller. So those points can be shared through our PPC. But those points, I think you can get, if you are the BMS engineer, you can get the points here through software integration. Okay. Now maybe I can show that one later also. But for this part one of my tutorial for water cooled chillers, I'm just giving you an idea. For the chiller part, what are the typical? So I'm referring to typical. Okay, okay. Now it will always based on the actual installation in the field. Now my tutorial is just a guide for beginners. Okay, especially those newly graduate who are wishing to join this building automation. I am giving you an idea what are in store for you if you will be able to land a job as a BMS engineer or a control engineer. What are the system waiting for you in the field? Okay. So guys, I think I have given you enough information for beginners. What is a water cooled chiller? Okay. Now guys, again, if you are new to my channel, you can always click the notification bell, and you can put your comments, you can and share the video, and thank you very much for joining me. And once again, before I will end this tutorial, I always say God bless us all, and